to talk about physical and chemical changes. Again, make sure you understand the difference between a physical change and a physical property, and a chemical change and a chemical property. A physical change is when we do what? Take a sheet of paper and tear it apart. That's a physical change. If I burn that paper, that is a chemical change. If that paper, if I take it from white and color it blue, that is a physical change. Okay? But if I say that paper is red, red is a physical property. Matter. To review, anything that has mass and takes up space or has volume. Okay? Matter. Matter makes up what? Everything. And matter is made up of what? Let's start with an E. L. Elements. Matter can be two things. It can be a pure substance, or it can be a mixture. Pure substances are elements such as carbon, helium, hydrogen, gold, copper, aluminum, lead, anything on the periodic table. Pure substances are also certain compounds. Carbon dioxide, CO2, water, H2O. Okay? Those are a couple that we're familiar with. Carbon monoxide, that comes gas. What do you think the formula for carbon monoxide would be? If carbon dioxide is CO2, what would carbon monoxide be? CO, because there's only one O. Okay? Mono, one. Mixtures are solutions that are like salt, water, tea, milk. Those are all solutions. Then we've got mechanical mixtures. Skittles, M&Ms, pizza, because they all keep their individual, what? Identity. You can see them. Captain Crunch, Raisin Bran. All of those are mechanical mixtures. Now, matter can be described as a physical property, which is a description of the substance. Example here, color, smell, taste, or density. All of those are physical properties. Chemical property describes how a substance reacts when mixed with other substances. Gas burns in heat and oxygen. Is oxygen flammable? Will oxygen burn? Well, which one is it? Yes or no? Oxygen burns? It makes the fire burn. Yeah, because if oxygen burned and we lit a match, what would happen to the air? It would burn up. There would be, yeah. So oxygen makes fire burn, but oxygen itself is not flammable. Now, how about hydrogen? Hydrogen is flammable. It will burn. Okay? Different gases have different properties. 3 phases of matter: solid, liquid, and gas. Solids. They have a definite shape and a definite volume. The particles are fixed and closely arranged, example, with ice out of water. We have to remember that everything solid is still made out of little bitty individual components. The amount of space in between those molecules determines the what of the object. The what? The density. If they're closely packed together tight, then that material is going to be really dense. If they're not packed real tightly, then it's not going to be as dense. Okay? Liquids, also known as fluids, they have a definite volume as well. Particles are free to move, so a liquid does not have a definite shape. Water conforms to whatever we pour it in, right? We take it in a glass. If it's a square glass, the water looks like it's a square in the glass. We take that same water and we pour it out on the table, and it goes everywhere. Makes a big mess. So, it goes freely. It moves around. Gases do not have a definite shape or a definite volume. Particles spread out, filling all the space available. Example, when we steam, heat up water, steam comes off. The steam goes where in the kitchen? Everywhere. Okay? It goes wherever there's free space to travel. Gases move about freely. Okay, you can put perfume on in the back corner of the room, and do you smell it up in the front corner? Yeah. Like we talked about with viruses. If someone sneezes back here in the corner, is the person up front safe? No. Because they move about in the air with the gases in the air. Okay? A physical change. A change that does not produce a new substance. We take water and freeze it, we get ice. But it's still only what? Water. Yes, ma'am. Yeah. It's usually reversible. Okay? We can take that same ice and we can thaw it out. And it becomes what again? Water. Dissolving salt. A lot of people don't understand the salt thing. They think of salt, put it in water, the salt disappears, and it's part of the water. But is it? No. If you take 2 tablespoons of salt, put them in a gallon of water, take that gallon of water, set it outside and let the water evaporate, what will be left in the bottom of the jug? How much? 2 tablespoons. Okay? The salt does not float up in the air. Therefore, when it's put in water, it does not break down. Water does not break the salt molecule down. Salt is sodium chloride, NaCl, H2O. When you combine H2O and NaCl, what you end up with is H2O and NaCl. You do not get something new. There's not a chemical reaction that takes place. That is a physical change. Physical change, a change that occurs that does not change the identity of the substance. When you put pepperoni on a pizza and cook it, it's still what? Pepperoni. You put mushrooms on the pizza and cook it, they stay mushrooms. Rooms of pizza. Okay? So, those don't change. Fruity Pebbles. They're all different colors, right? Fruit Loops. All different colors. Melting ice. Is that a change in state or phase? It's what? The same thing, right? Freezing Kool-Aid. That is chemical or physical? Physical. Tearing paper. When I tear your paper up because you've been caught cheating, it's still a piece of what? Paper. Boiling water, okay, it's just a physical change. Same as the melting. Physical versus chemical. Physical properties, characteristics of matter that can be seen and measured. Okay, we can see the color of something. We can feel the texture. Okay, whether it's smooth, rough, satiny, velvet, coarse. Okay, kind of like your hair. Some people have coarse hair. Some people have fine hair. Some people's hair is shiny. Some people's hair is dull. Okay, some people's hair are oily. Some people's hair is dry. Okay, we can see that, right? Some people's hair is salt and pepper. Some people's hair is gone. Some people can have salt and pepper and gone. All right. So the shape. Shape is physical. Some can have nice trim shapes. Some can have Santa Claus shapes. Size. Some people are tall. Some people are short. Mass. Lord have mercy. Some people have more mass than others. Okay? Odor. Here's a good one. Some people sure have different odors than others. Okay? You know, anybody got pigs at home? Anybody got chickens? Grandma got chickens. When you go in the chicken pen, different kind of odor there than is the flower garden. Okay? Freezing point. As you get older, I think your freezing point changes. Okay, 40 used to be warm, now 40 is freezing. Boiling point, if you teach, your blood has a different boiling point. Okay? Just saying. Density, different substances have different amounts of matter. That's a physical. Volume, the amount of material an object will hold or consumes, those are all physical. They have nothing to do with chemical. These are all physical properties. A physical change, the substance changes what it looks like, the form of the substance changes, a change of state, melting, freezing, sublimation, condensation, evaporation. Those are all changes in their physical shape and identity of the substance. Dissolving a substance, Kool-Aid, dissolving in water. Okay? It still is what? Kool-Aid. Breaking an object. If you take your pencil and break it in half, it's still what? A pencil. Okay? Cutting a substance. We got a cake on the table, we cut it. It's not have the same shape anymore, but it's still a cake. We didn't change it. Those are physical changes. Chemical change. That's a little different. We take an egg and we cook it. Is that physical or chemical? Chemical. Because we can't uncook that egg, can we? No. So chemical changes are a reaction takes place creating a new substance. It's usually hard or impossible to reverse. We can't unboil that egg. Okay? We can't unscramble that egg. We can't unburn that toast. Okay? We can't unbake that potato. The heat causes a chemical reaction to take place. Chemical changes. Chemical change is a change that occurs causing the identity of the substance to change. Burning something, digesting food is a chemical change. We break down the glucose that the plant has made, and in turn we use that for what? Starts with an E. Energy. Do we use protein for energy? No. For the umpteenth time, no. Reacting with other substances. Okay? You put two highly volatile chemicals together and you can have a problem. We saw that with water and magnesium. Causes and what? Explosion. A chemical change is called a chemical reaction. Okay? If you clean the toilet, you don't put Clorox in the toilet and leave it. Anybody know why? Why, Harlan? Yep. If you leave Clorox in the toilet and you go pee, your pee contains ammonia. Ammonia and Clorox don't mix well together. They create a toxic gas. Okay? So, that's a problem. That's a problem when you're cleaning the house. A lot of people say, well, I'm going to get this stuff off my floor one way or the other. And they just start throwing stuff on it. One chemical after another. My daddy done that when I was little. We were trying to get the wax off the floor. We had to evacuate the house. There was a cloud formed in there, looked like fog. Because he used every chemical we had. Could have killed us all. But that's a chemical reaction. Indicators of a chemical change. There are certain things that we can see happening that let us know if there's a chemical change taking place. Evolution of light. If something gives off light, then there's a chemical reaction taking place. If it gives off heat, okay, the hand warmers that you get in the wintertime, you take them out of the package and you shake them up, you're exposing them to the oxygen in the air, the two chemicals are mixing, and they start getting hot. Now, is that an exothermic or an endothermic reaction? Exo, why? It's outside, giving heat off. Endothermic means it's pulling heat in. Okay? Just a little tidbit there. This also happens with the glow-in-the-dark necklaces and glow sticks. What do you do when you get a glow stick? You crack it, right? You break it. Well, what happens is two chemicals mix together inside of it. And that's what causes those chemicals to glow and light up, is the two chemicals mixing. The chemical reaction gives off light. Evolution of a gas. Okay? We just talked about that with ammonia and Clorox. They give off a toxic gas. Okay? But if a gas comes off, then it's a chemical reaction. Color change. Okay? If you go dye your hair, you have to use what? Chemicals, right? Now, the stuff you spray on, is that physical or chemical? Okay? But the stuff you put on there that stinks, that makes a brunette blonde, that's what kind of reaction? It's permanent. It don't wash out, right? When I do my hair pink or blue, it washes out. As soon as I hit the Dunkin' Booth. That's physical. Now, if I went and got it dyed for real, it wouldn't change, would it? Formation of a precipitate. Precipitate is a solid that is formed whenever two liquids are mixed. So I can take two liquids, pour them together, and a solid is formed. It makes something solid. Because the chemicals break down, they recombine, and the recombination is a solid, a different substance. The substance, in a chemical change, the substance changes what it is. A new substance is formed. Heat, light, energy, and gas is given off. Burning something, cooking something. When something rots, does it stay the same as it was? No. Souring, milk. When milk sours, can you unsour it? No. And it sure ain't what it was. Totally different, right? Spoiling. Meat goes bad. Can you unspoil that meat? No. A precipitate or a solid is formed. Color change or rust forms. Once the car rusts out, can we fix that just by wiping the rust off? No. Okay? It's permanently changed that metal on the car, and it's not nearly as strong and as dense as it once was. Chemical properties, characteristics of matter that influence their reactivity with other substances. The formation of new substances. The ability to rust is a property, not a reaction. Flammability, okay, is again a property, not a chemical change. Reaction with acids, spoiling, combustibility, okay? All of these are chemical properties. You notice a lot of them have the word ability in them somehow. The ability to, flammability, combustibility, okay? Looking for keywords that help identify. Remember, some things that hint at a chemical change is taking place. Okay, cheat notes, for example, is what these are. If I see heat or light given off, more than likely there's been a what? A what? A chemical change. Hello? Bubbles of gas are given off. A precipitate is formed. The change is difficult to reverse. All of those are little indicators that we can immediately look for to see if a chemical change has taken place. Gummy bears, infernos. Okay? If I take gummy bears, which are sugar, and add oxygen, and I burn them, what am I going to get released? Carbon dioxide and water. They change. Sugar, C6H12O6. Remember that from previous lessons. And oxygen, then I get carbon dioxide and water. In a chemical change, there are clues that a change occurred. What are the changes? Heat, light. We just covered them. Gas, precipitate. Okay? You need to know those. You need to understand those for a test. There are 5 clues that a chemical change may have occurred. A new color appears. Okay, if I mix 2 liquids together, a yellow and an orange, and I get blue, something has happened, right? I've got a new color. Heat or light is given off. Bubbles of gas are formed. If I drop an Alka-Seltzer into a thing of water, anybody ever seen Alka-Seltzer? The little plop, plop, fizz, fizz, oh, what a relief it is. Okay? Not only that, but what happens if you take a Mentos and put it in a bottle of Coke? It's going to explode. Why? The gas that's in the drink is combined with part of the Mentos, and the gas given off creates pressure, and eventually the bottle will go boom. Okay? So bubbles of gas are formed. We've got a chemical reaction taking place. A new solid material forms. A precipitate. Okay? A new odor is made. Fresh marshmallow versus a burnt marshmallow. Is there a different smell involved? Biscuits smell great in the oven, right? Until you leave them in there too long. Then what happens? They stink. Okay? Bacon smells, popcorn, oh my God, popcorn. Popcorn smells great cooking, right? But once you burn popcorn,
oh my God,
it stays forever. Okay? And it just stinks. A new odor is formed. That's a burnt marshmallow. Why people eat them like that is beyond me. All right, little quiz. Rusting nails, A or B? Chemical. Effervescent tablet or Alka-Seltzer? Chemical. Physical, cutting paper. Vinegar and baking soda? Chemical. Salt and water? Physical. Still going to be salt. Got to be careful. Broken glass? Physical. Burning wood? Chemical. Ice melting? Physical. Removing iron filings from a mixture? Physical. You can take, on a side note, you can take cereal, pound it into a powder, and you can take a magnet and you can pull iron out of cereal. When you look on the side of the cereal box, it'll say it contains iron. Iron is good for us, but iron is really iron. It's metal. Okay? No. Just kidding. Yeah, I mean, if you're low on iron, you can't give blood. Well, not necessarily that. Some people have to take iron supplements. You get anemic, you're low on iron. A lot of people's body don't retain the iron like they're supposed to, and they have to take supplements. Boiling water. Physical. Okay?